This simple, ancient invention powers our entire modern world. Think about every complex machine you encounter daily. From your car to your watch, a silent hero is at work. Today, we unravel the hidden science behind gears. These unassuming cogs are fundamental to mechanical engineering. They manipulate force and motion with elegant precision. Understanding gears unlocks the secrets of many devices. Let's explore how these mechanical marvels truly function. The concept of gears dates back over 2 millennia. Ancient Greek engineers were pioneers in gear technology. Archimedes in the 3rd century BC described their principles. His work laid foundation for complex mechanical systems. The Antikythera Mechanism, around 100 BC, is astonishing. This ancient Greek device used 30 bronze gears precisely. It calculated astronomical positions with incredible accuracy. Gears are masters of mechanical advantage and force. They allow us to exchange speed for increased torque, or vice versa. A small gear driving a large gear multiplies turning force. This principle is crucial for heavy lifting machinery. Conversely, a large gear driving a smaller one increases speed. Functional purpose, think of it effectively. Bicycles' multiple gear settings for varying terrain. Gear ratios precisely determine this power and speed transfer. Functional purpose, think of it effectively. Spur gears are common, with straight teeth on parallel shafts. They are found in simple clockwork and industrial machinery. Bevel gears connect shafts at angles, often 90 degrees. Car differentials use bevel gears for smooth cornering. Worm gears provide massive speed reduction and self-locking. They are perfect for heavy loads requiring precise control. Planetary gears nested within each other offer compactness. Automatic transmissions and electric drills utilize this design. Smoother operation than society spur gears. Their angled teeth engage gradually, reducing noise and vibration. Smoother operation than society spur gears profoundly relies on advanced gear systems. Wind turbines use colossal gears to generate electricity. Robotics employs tiny, precise gears for delicate movements. Aerospace engineering demands ultra-reliable, lightweight gears. From elevators to power tools, gears enable our daily lives. They are critical components in almost every modern machine. The simple gear, often overlooked, is a true engineering marvel. Its scientific principles continue to drive innovation forward. Gears demonstrate elegant physics applied to practical problems.
They are a testament to human ingenuity and scientific insight. Next time you see a machine, appreciate its intricate gears.
Subscribe for more in-depth explorations into how things work.